Hey guys, welcome back to the Beginner's Guide to Restoring Early 2-Base Black and White Televisions. I'm picking up right where we left off in the last installment, in which we tested capacitors and discovered that when tested at their maximum ratings, they all failed. So we're going to talk about the types that they used back then and what we can replace them with today. What is available, what is being manufactured today that is the equivalent. Now, as I pointed out in the last video, even though these failed at their maximum specifications, it does not mean that they do not work, will not work, absolutely have to be replaced for the set to function. We already have powered it up. We already know that it kind of does something. Because none of these parts are going to be run at their absolute maximum specs. They're going to be running somewhat below that. When they designed this, when they selected components to use, they always, well, if it's well designed, they always give themselves some headroom. 20, 30, 50% headroom. In other words, if the circuit has 200 volts on it, let's put a 300 volt, a 400 volt cap in there. Gives us a little safety margin. All right. But I am going to replace all of these. I'm not going to tell you you have to. You do what you want. But I want to not have to worry about it. And parts don't cost that much, generally speaking, so I'm going to replace them. All right, I'd start out with the electrolytic cap. We tested this guy up here. Let's start with the electrolytics. We have two of them. They are metal aluminum tubes that have one or more capacitors inside of them, the negative leads of which all go to the can itself, and in this case that can is connected right to the metal chassis. Everything is grounded. We have one or more lugs coming out of the bottom. Those are the positive ends of the electrolytic capacitors. We tested this one. We tested one half of it anyways, and it's leaky. I'm going to assume the other half is bad. That's usually the case. So we want to replace both of them. What can we replace them with? They are no longer made generally. They're not generally available. However, curiously, somebody bought equipment from, I believe it was Mallory, who used to make these. The FP type. It's a very common early type. That might be what these are. And they are making them again. Supposedly with the same formulation and materials used originally. Now, I've never seen published specs on these caps. Admiral may very well have done a special order directly from a capacitor manufacturer. We probably never know what the specs are. The newly manufactured ones, however, do have specs published. You can take a look yourself. But we can't say for certain whether or not they meet the specs of what was used in this. However, this is not laboratory grade stuff. I'm sure they work fine. They're expensive. 35, 40 bucks or more per can. So we might be looking at 80 bucks to replace these two if we went with that. There's also one or more companies that will take a metal tube and put individual modern caps inside. It'll look like this type of cap, but inside it's not. That's certainly another option. Or we can just buy our own modern caps and install them. This is what I'm talking about. They no longer make caps that are in multi-sections. They're individual. So this, for example, is a 47 microfarad 450 volt cap. It's a fine replacement for one section of this. We have two sections to replace. You can take two of these, connect the negative leads together, solder them to the chassis, take these wires and go to the positive side. But you have to mount it somewhere. These come in two styles. Axial, meaning it's like a car axle where they come out of the ends. These are rapidly disappearing because most things are on circuit boards these days. And this type are radial, where they come out of both ends, and these are more friendly with mounting on circuit boards. So this is the vast majority of caps made these days have both leads coming out of one end. Okay, so we need to mount them somewheres. You have a few options. One, you can take the old can out. I will show you what one looks like in more detail. This is what a brand new one looks like. It is possible to uncrimp this seal or file it down or cut the can open, remove all the guts, drill little holes in the end of this phenolic board here, and attach your leads and mount it back up. In other words, restuff the old can. Take all the old stuff out. It does not have PCBs in it. It's not toxic. Don't worry about it. I've done that in the past. If you watch my really old videos, I used to do that. I don't anymore. Why? Because I don't have unlimited time. I have a lot of projects to get to. My customers do not care, generally. If somebody requests that I do, I will, but no one ever has. So I don't these days. But what I do often do is just leave the old cap up there. There's plenty of room down here to mount the new caps. There is one consideration on something like this, because this does have a board and it's sealed down here. So it might get a little toasty down here. The number one enemy of electrolytic caps is heat. That's one reason they mount them above, and they're in a metal can. So imagine these old ones. If they get warm, they can radiate the heat into the environment very, very readily. These old ones, not so much. Or sorry, the new ones, not so much. Not if we mount them underneath the chassis. Now, I have experience with these. There's not a whole lot going on down here. It doesn't get that warm. But if you run it for a long time, the heat up top, because this is all metal, does start to come down here, and it will get a little warmer. There's another factor, which is temperature rating. Your common variety caps, in other words, if you go to a website like Mouser or DigiKey, I'll talk more about where you can get parts later, there's what they call general purpose capacitors, which have general purpose ratings, meaning they're just meant for a wide variety of non-critical applications. They will typically be rated for 85 degrees Celsius, and they'll have a moderate lifespan, they'll have moderate leakage current, moderate ESR ratings, and so on. And they'll be relatively inexpensive. But if you spend maybe twice as much, 3 times as much, you can get capacitors rated for 105 degrees Celsius, or even 125 degrees Celsius, with lower ESR, longer lifespan, more current handling ripple current handling capabilities. It really comes down to how much do you want to spend. You have options, which is great. Options are always great. But just by all means, if this is your prize TV and you're going to restore one and it's a family heirloom or something like that, knock yourself out. You can even custom order these, I do believe. And you get, handcrafted parts if you want, or use off-the-shelf parts. You have a range. You get the lowest grade general purpose caps, a 47 microfarad 450 volt cap. $1, $2. Top of the top shelf, $5, $6, $7 a pop. Okay, so let's assume we're going to go with individual caps. Like I said, you can leave the cap up there and disconnect the wires and mount it somewhere. Where are you going to mount it? Well, you got a few options if you're not going to restuff. You can drill a hole in here and add a terminal strip, reroute the wires a little bit and mount your caps. Throw a terminal strip in there and mount a couple caps horizontally nearby. What you don't want to do is put them in parallel with the old cap and leave the old cap in circuit, because it may fail at some point and cause you problems. I'll see that sometimes in old repairs. I just tack a new cap parallel with the old cap. Do not do that. Another option is trace out the wiring and see where it goes. For example, this is the wire going to that cap. It goes right over to this tube socket. And the other wiring. We could remove this wire and relocate our cap and put the positive lead right to this tube socket pin and tack the negative to this grounding collar here. and we could mount the cap over here. Not have to disturb anything. I'm not crazy about drilling holes into things if I don't have to. So I do often do that. Again, though, the one consideration is right on the other side of this is a 5U4 rectifier. It gets pretty toasty. If I mount the cap here, it's gonna get a little warm if I run this for an extended period of time. This is a 105 degree cap. It's relatively large as these go. I'm not that concerned about it. I also have a terminal strip over here, which you may find some unused lugs, or there's an unused lug right here. So you could potentially mount a cap over there. Got another terminal strip over here you might be able to use some lugs on, if you want to do that. I tend to do that when I can, is I relocate parts. Yeah, it does make it confusing for the next guy down the line who works on this, because it won't match the service info quite anymore. But boy, it is convenient at times. But there's another option these days. Watch my videos if you've heard me talk about this. Adapt-a-cap. This is a little circuit board. Comes on this kind of business card thing. Here's what it looks like when you pop it out. Looks a lot like the metal plate down here, doesn't it? Yeah, a lot of these chassis, they not only have holes for the twist locks, but there's also a couple rivets and there's a metal plate there. They designed it to take two different styles of caps. One that would be mounted on a phenolic board that would look something like this, the other is a twist lock. So we could untwist these twist locks, remove this cap entirely, drill out these rivets, and the mounting holes on this circuit board would line up perfectly and it would drop right in. Okay, well, what's the circuit board all about? This has a whole bunch of holes drilled on it. This is meant for mounting modern axial leaded caps to this. You mount this to the chassis, you run your wires to these holes. I've been using these a lot lately. Supposedly he's working on other variations where you could potentially reattach the metal can. You could hollow this out. And even with this version, if you got creative, you could hollow this out. One easy way to do is to file this down and the can just pulls away from the insides. And then you just have to figure out a way, glue, solder some tabs onto it, something, so you can attach it to this little board. Then you can hide your new caps inside of it. It's one possibility. Generally, I just leave the new caps visible. One thing, it's nice to keep an eye on them in case there is ever a failure. These have a cross on top. If these fail, the top is meant to vent. If these overheat, it's nice to be able to see them so you can check to see if they're healthy, see if they need to be replaced. Also, if you do go with these, the hole spacing on them is 5 millimeters. If I was to use a cap like this, I would have to bend and contort the leads to get it to fit. But these days, more and more caps are these skinny caps, where instead of short and fat, they're long and skinny. And they have 5 millimeter spacing, and they just go right into these holes. Alright, that's probably what I'll do with this set when we get to it. Now you may have noticed I opened up the bag and pulled this cap out of it. Where the heck did I get this? This was a common failure point, not only now, but back then, and there were millions of these made. This happens to be a Zenith replacement part. I got a whole box of Sprague and Mallory new old stock electrolytics out in the garage. Could you use one of these caps that's about as old as this that were never used? Well, if you find one that has the right value, this is not. This is 80, 80, and 15. We need a dual 40 at 450 volts. But if I hunted through these bags, I might find one. Certainly considering this is 50 plus years old and it's never been used, it will need to get formed up just as the old ones did. Same problem. These just sitting around, even new caps, if they've been sitting around a few years, they all need to get reformed. This could have dried out, the seal could have failed, the chemicals inside could have broken down, paper insulators inside could have deteriorated. It's probably in better shape than one that was used in a set, but then again, the one that was used in a set was getting reformed, at least while it was being used, so this might actually be worse. It's a crapshoot. Well, maybe I'll do a separate video and check some of these out, but I wouldn't use it. I wouldn't use it. At least we can look at it. It's kind of interesting to see what's on here. So you get the part number, specs, can, common, negative. That's all it says on this. Usually they say 85C. They're all rated for 85 degrees Celsius. And usually they give you a tolerance, and often it was plus 80%, minus 20%, something like that. These were not precise devices. The huge range. That's why when people ask, well, what can I replace them with? You're like, something that's close. What does close mean? Well, the original spec was plus 80%, minus 20%. We're replacing a 40. So close means 33 to 82, something in that ballpark. But 47 is a really common value, so that's what we're going to go with. They don't make 40s anymore. Just like with other component values, we'll get to, things changed over time. Originally, they would make parts that were capacitors. 10 microfarad, 20, 40, 80, 100. Now they go 10, 22, 33, 47, 56, 82, 100. Why? There's a very good reason. It's a mathematical projection of, I think if you double the value every time, I forget what the exact mathematical sequence is, but it makes more sense to use the modern values. And they switched over back in the 50s. So it's not a recent change. It's an engineering change. It's parts practicality in terms of getting their... So when they design these circuits, they use their formulas or whatever, and they come up with a value that would be ideal. Then they have to translate that into what they can buy. And it turns out that going with the 22, 33, 47, etc., it works out better. I hope that made some sense. Let's talk about these guys, the paper caps, whether they're in a plastic tube or dipped in wax. I want to replace them all. We have even more options for these. They're still very widely used in a lot of stuff. Just like with the electrolytic, you can get boutique hand-rolled caps. Places even make paper caps, believe it or not, in plastic tubes with stripes that look pretty much like these do. If you want to pay $20 a cap, knock yourself out. You can also get something like this. This is a Janssen audio cap made in Denmark. I think these might be hand-rolled too. At any rate, they're made from very high quality metal foil, plastic material, rolled up, sealed, audiophile grade, whatever that might mean. Solon Fast Cap is another one. Some of them use different plastic like polystyrene, which is a fantastic dielectric, but not made so much anymore because they tend to melt at low temperatures. You have to be careful when you solder with them. Then there's the more common stuff. The vast majority of restorers, be it radio or TV or whatnot, use these guys. Generic, no name, yellow, axial caps, widely available from many hobbyist supply vendors. I mostly use these guys these days, which say MPT on them, and they have green on the ends. This one has no manufacturer's name. It just has a parts value and a voltage rating. I don't know who made these. I can't look up specs on them. All I have is anecdotal evidence that a lot of people use these. I've used them. I used to kind of turn my nose at them a bit when I first started working on this stuff because I couldn't look anything up. I didn't know who made them. I gotta be realistic. They're widely available. They're inexpensive. I've never had a problem with them. Very few other folks have had trouble with them. There's guys in the antique radio forum that restore radios for a living that have used thousands of these generic yellow types. They're fine. They're fine. We're not going to the moon. We don't need mil-spec parts. Used to be you could get some, but I don't think any manufacturers make axial plastic film caps anymore. I used to use these, which are made by Mallory P150s. They stopped making them maybe 10 years ago. You might still find some of these floating around out there. These have a pretty long shelf life, so I wouldn't hesitate to use a 10, 15-year-old plastic film cap. No, nothing lasts forever, but 10, 15, 20-year-old high-quality plastic cap that's been sitting in a parts bin, it'll be fine. You may have heard of the legendary Sprague orange drop caps. I'm pretty sure these are still made. The owners have changed over the years. I think Vichy owns them. Vichy owns just about everybody these days, like Omite and Clarostat, and they, over the years, bought up a lot of the old school brands. I have no problem with Vichy. They keep making the stuff. It seems to be decent quality. It's readily available. So you can buy orange drops. These are real foil caps. What do I mean by that? Well, notice how much larger it is. This is made of polypropylene, plastic film, and I believe aluminum foil. And they roll it up just like the old ones were. Just instead of paper, they're using plastic. And yes, they do usually mark the outside foil. They cost more, they're bigger, they will absolutely work just fine. These other types, the less expensive types, are metallized film. It's a very, very thin layer of aluminum that's vacuum deposited onto either polypropylene or polyester, or perhaps polystyrene plastic film. Polystyrene, getting pretty hard to find though. Think about a Mylar balloon. The metal layer is so thin you can see right through it. That's why these are smaller. Because of that, they're less robust. Again, for what we're doing, any one of these will work just fine. Another option, so the major manufacturers don't make these axial types anymore. What do they make? They make radial for mounting on circuit boards, where both leads come out of one side. But Panasonic makes them, Nichicon makes them. Those would be the two major players. And a huge range of part component values and voltage ratings. They're relatively inexpensive. I've used plenty of these in the past. The problem with them is, if you want to replace one of these big old bumblebees with leads going out the ends to distant points, well, you have to take your axial leads and bend them over and maybe add some extension leads because they aren't going to be long enough. That's annoying. That's annoying. So that's why I've been drifting more over to using these lately. Even though I can't look up specs, I don't know who made them, I don't know what they're made out of. I haven't had a problem using them. So there you go. Spend as much as you care to spend, whether you're getting hand-rolled boutique caps or still-made high-quality caps, name brand caps you have to manipulate the leads with, or no-name yellow caps. I doubt you'd have any trouble using any of them. Do whatever you feel comfortable doing and whatever you can afford to achieve the goals that you want to achieve. Now, as far as actually replacing the paper caps, that's a bit more work often because the leads go to lugs or terminal strips, and they might be buried under several other parts, like this cap down here has got several other parts on top of it. This is where you want to get your needle nose pliers, your solder sucker desoldering braid, your little wire nippers, and get in there. The easiest way to do it, if you don't care about appearance, you want to get the job done reliably, safely, easily, cut the leads off near the body of the cap, leave the old leads there, and bend the very end of it into a hook. Take your new cap and bend the end of it into a hook, a J, and hook them together, crimp them together, and then solder them together, and then cut off the excess leads. It's called J hooking, typically. It'll look a little ugly, But if you do a good job with your crimping and soldering, it's very sound, very reliable. And one big benefit, aside from it, you don't get lost in your work because you're leaving the little leads there. But you don't have to disturb. You don't have to get them right down in there. If you go down to the tube socket and you want to remove all the traces of the old lead, clean out the old solder, you can do a few things. Unfortunately, if you flux this too much, you can break it right off. You can melt the insulation on the wires going to it. Some of these are plastic, and this is old plastic. You start heating up this joint for any length of time, this plastic starts to pull back and melt. That's no good. You can also have a lot of trouble just getting all the remains of the old lead out, and it's going to take you time if you have to get this all. If you want to get all the old solder out. But if you've got time and your patience and it's fundy for you, by all means do it. I certainly have plenty of times. The leads, you may notice on this one it has a bit of something over it. If you've got a number of parts coming together, you may want to put some insulation over the leads. This is the old school stuff, made out of some temperature resistant material. These days you can get spaghetti tubing or heat shrink tubing. I just buy a big old roll of this stuff. Heat shrink tubing. This will last me, I think about 1,000 feet. It'll last me decades probably. Actually, it's only 100 feet, but it feels like 1,000 because you don't use very much. And you just snip off a little piece and slide it over the ends of the leads, and then go ahead and put it in the set and solder it in. In most cases, though, there's nothing on these leads. There's enough clearance, you don't have to worry about it. But if you want some extra safety, by all means, put some insulating tubing over your component leads before you install them. I highly recommend you make photocopies of your schematic, parts locator, whatever service info you have, and as you're going through doing these, identify it, replace it, and then mark it off with a highlighter or something that you have replaced it. One, it's good that it helps you familiarize yourself with reading a schematic and how to identify parts and where they go, and familiarize yourself with the set. If you do any troubleshooting, you'd be somewhat familiar with where the parts are located. And of course, you keep track of your work. And there's always reference photos are very handy. I might replace all these caps in one shot, but I will replace them one at a time. I'm not going to clip them all out and then replace them all. Clip, replace, clip, replace, clip, replace. And I generally clip one end off and attach my new cap to that end and then do the other end. So it really, really decreases your chances of getting lost in your work, especially if you get called away from the action and you come back later, you don't remember where you left off. If you just do one part at a time, it should help out a lot with that. Alright, so I'm going to go through and replace all these paper caps. Alright, 5 caps down. That actually went quite smoothly. In a lot of cases, I was able to remove all traces of the old lead. Sometimes I left the lead there and there was enough room left in the solder lug. I just shoved the new component lead through it. And in 1 or 2 cases I just wrapped it around the terminal strip, and I even did reuse a little bit of insulation on this one lead. The electrolytics I'm going to leave for now. I reconnected this top guy. Yeah, they were a little bit leaky at full voltage. But I want to move on to some other stuff. I can tell you right now, I could spend the time and remove this and put new caps in and all that. It's going to make little, if any, difference whatsoever on the set's performance. We got plenty of other issues to deal with first. Also want to point out that when you take the tubes out, it's very easy to work on this because it's supported by these caps and the transformers. You want to put some paper towel down or something so you don't scuff up the nice paint job on those transformers, but otherwise, with the two big tubes out of the way, very stable, very easy to work on like this. Alright, that's going to be it for now. Next we pick up let's start taking a look at the main chassis and doing some troubleshooting. Thanks for watching.